reason my brain doesn't accept the answer.
So just to give you a little grace, we've learned like what second derivative means, all this kind of stuff, right? So then after we do that, it sort of becomes a little jumbled. And we've been talking about what's first derivative means since
Over and over.
yeah. But when we add extra stuff on top, then it starts to get jumbled.
Am I the only person in this room that actually prefers it when the lights are off?
Probably not. But I don't like it that way either. I'm the most important person. No. So, what does the first derivative tell you directly? Good. It's a function that tells you the slope at a point if you plug the point's x value with it. You guys with me? Oh wow, that's it. Wait a minute. So bear with me. That is what it tells you immediately. What does that lead to knowing about the graph of the function?
Critical numbers.
Okay, but it tells you if the function's going down or up, so increasing, decreasing. So you don't have to memorize all this. I'm hoping it just kind of makes sense. If that's the slope function, it tells me what the slope is. Obviously, if the slope is negative, it's going down. So if the first derivative is negative, it's going down. So it's not extra stuff to memorize, it's just a consequence of the fact that it tells me the slope, yes? Then that leads to, well, if it's going down and then going back up, that must be a minimum. That's a consequence of it went down and went back up, or it goes up and goes back down. Yes? And that's why when I see plus minus changing around a critical number, that must be a local extreme. Exactly. Maybe? So a lot of students try to break math down into, what do I have to memorize? What do I memorize? No. Here's the idea. What does that lead to? What does that lead to? What does that lead to? Yes? If I had to memorize every damn thing that I'm able to do, like I think I told you, I'd be in a corner somewhere because I've forgotten how to be because it's all replaced with all this math shit. You guys kind of with me? So it's more fundamental stuff. So first derivative tells you slope, which leads to increasing, decreasing, which leads to max and min. What does second derivative tell us? Concavity, right?
Inflection points.
Which leads to inflection points, yes? Now, concavity, we worked with less overall, yes? Because we worked with first derivative a ton, and then we just sort of threw second derivative in there. There's not as much to say about concavity because it is a little bit tricky, yes? So at least concavity might be a little easier to categorize in your head because it's its own kind of little tricky thing. We'll see. Okay. Is that okay? All right.
And then the critical numbers,
Yes.
when you input them into the original problem, you're finding a point.
Yes, anytime you use the original function, the output will be the y part of a point. Yes? If you use the first derivative, the output will be the slope at that location. If you use the second derivative, it'll be the concavity at that location. Kick ass. Yes.
Yeah, because I think when I walked out after taking the quiz last week, I realized I used the wrong derivative for the inflection points,
Oh yeah.
which
yeah.
messed up my whole
That
problem.
totally freaks things out. Because then you have somehow max is also an inflection point. You're like,
Yeah,
how the shit does that work?
I knew it when I was leaving. I go,
I'm with you. How we do another way? Any questions from the quiz itself? Today is going to be complete review day. What's the highest homework you got to turn in on Wednesday?
4.7.
4.7. I like it. Does that mean we're not going to do 4.8? No, we'll talk about 4.8, 4.9 after this test. Yes. So today is purely review. We can work on quiz corrections, we can work on practice test problems. I've got the answer key for the practice test, so like I said earlier, if you're like done with listening to me, you're like, God, this guy's voice is like chocolate and chocolate. Get the shit out of here, just stop for a second, get the practice test answer key. I'll give it out later. Oh yeah, maybe, let's see, hold on. Yes, I do. Does anyone need an actual practice test?
Yes.
Does anyone else need a practice test? Does anyone else need a practice test? Okay.
So,
See? Number 1.
on the practice test.
So guys, when it says find the linearization, what's a better way to reword that?
Find the element.
Huh?
The element. F of A plus F prime of A. times
Okay, sure.
X minus
Okay. So if you want to, you can memorize the section's linearization formula. Do you guys remember why that's kind of silly? It's just finding the
First.
tangent line. That's all it is. Now, on a different level, we saw. It is kind of good to know this exists. The linearization is f of a plus f prime of I times x minus a. Yes? That's the official linearization formula. You guys are. But I need you to understand, real quick, what's the equation of a line? Y minus, here, I'll do that.
1 equals X, M times X 1, yeah.
If I add y1 over, if I rename this a, m comes from the derivative evaluated at a, and y1 comes from evaluating the function at a, yes? They're the same stupid thing, correct? So part of me hates the fact that we have a whole separate section that treats it like it's brand new stuff, yes? But there is an idea in 280 that if you remember this, and whoever you take me, I'm gonna bring this up, but it just takes this and it improves on it. It adds more derivatives to make the curve fit better. So I like to reference this kind of thing and say, oh, we're just adding more derivative information to make the curve fit better. But for right now, it's just a practical application of finding tangent lines. Right? There's a purpose besides just, can you make a line? So making a tangent line, it's an approximation for the original function. It kicks ass. So, even if you don't want to memorize this, and I would be cool if you didn't, you just have to say, how do I find the tangent line of a function at a value? What two things do I need for the equation of any line in the universe?
X 1.
What two things do I need for the equation of any line in the universe? Slope and a point. Right? How do we get the slope?
Second derivative, first derivative.
First derivative. Mike, come on, man. Please. So yeah, if you take the first derivative, you can then plug the value in to see what the slope is there. Yes? You guys with me? Right? If you take the derivative of this and you plug -2 in, you'll see what the slope is there. That's the slope. That's the slope. And then this is just plugging -2 into the function, yeah? Let me stop for a minute. We have found the tangent line for so many things. Do you agree with me? You've seen that question pop up so many times. This is the same problem, except it goes one step further. It says, oh yeah, that line you just made, let's use it to do something. What do you think? Right? And from your perspective, you should be like, well, finally, shit. Don't just make a tangent line and go, look what I did, I made a line. No, go, what can I use the damn thing for? Is there a reason I want to do this? Besides to check off this box in my homework that says, do this. Right? So, is that enough to go on for that one, or? What's the derivative? What's the derivative of the function?
1 over x.
What? Yeah, no.
1 over.
What's the derivative of natural log of stuff? 1 over stuff times derivative of stuff, right? But the inside's derivative is 1, so it's just 1 over stuff. So f prime is this. So now you can plug a -2 in. What do you get when you plug a -2 into the function? Natural log of? No. -2 plus 3. 1. Natural log of 1 is 0.
0.
So we know we've got the point -2, 0. That's my point. And what's my slope? What's f prime of -2? One. Yes? 1 over 1 is 1. And then you just plug that stuff in. You just build a tangent line like you always have. If you'd rather, there's not a damn thing wrong with memorizing this. Just remember it's nothing new. It's just repackaging something we already knew. Yes? So you get a remarkably simple linear approximation. What's the caveat? It's a word I don't use much. What's the give and take here? What's the catch? I could only use that line I find. Could I use it for any input? Will it be good for any input, the line we create? It's only really good if my inputs are close to -2, yes? And the idea of close depends on how close I need my answer to be. You guys kind of with me? Natural log isn't like a crazy function, so especially over by -2. Well, -2 is it gets a little bit crazy. So you have a tighter window, but still, it's not too bad. It's not like some insane cosine function going crazy. If you guys are with me or not. So if I have an insane function that's just going up and down really tight, if I just move a little bit, I'm completely in a different place. Yes? And that's when close is like stupid close. But if I have a function that's kind of like, then close could be a little bit further away because my outputs aren't going crazy. My slopes aren't changing quickly. Okay, maybe. There's a lot in this idea of linearization. If I have a function that is differentiable at a point, I can zoom in enough where it becomes linear. That is the idea. If I have a function that's not differentiable at a point, I can zoom in forever and it never becomes linear. Okay, maybe. Screw you, Jeff. So what function do you get? Y equals x plus 2. Yeah, 0 plus 1 times x minus -2. I get y equals x plus 2. But here's the trick. How do I evaluate natural log of 1.03? Do I just plug 1.03 in? Why not? Why can't I? Because what is the function we just built things around? What function did we just build y equals x plus 2? What function did we build that based on? Natural log of x plus 3. So now it says, okay, I want you to evaluate this. We have to ask ourselves what x value makes that happen. That's the x value we have to use. Again, just make x 1.03. No, my function isn't natural log of x. So it's not saying x is 1.03. So how the shit do you figure out what x is?
I mean, we technically just need to figure out, well, we look at, like,
want this to be? What do I want to be in here?
You want x plus 3.
What do I want to be in there?
1.03.
1.03. So make x plus 3 equal 1.03. Let's solve it.
Yeah, that's what I was gonna say.
Okay.
Yeah, I mean,
You don't make x something, you solve for it.
yeah, I mean, we technically would just put x plus 3 equals 1.03.
Yeah.
So you just pick a value that makes
No.
sense of it.
No,
You know,
you solve for x. Subtract 3. That's all. Right?
Yeah,
No guess and check.
well, no, of course not. Guess it's
Okay.
I mean, yeah, you pick a value that makes sense by doing the math.
Okay. Is that okay?
How easy? Yes,
I know. That's why it didn't make sense what you were saying. Okay. So I mean, you have to do a little side quest, right? X plus 3 is 1.03. Subtract 3, get what x has to be, and that's what you plug in here. And the beautiful thing is, all right, real quick, can somebody solve that for me? X plus 3 equals 1.03. What's the answer? Negative 1.97. What is true about negative 1.97 that tells me my approximation should probably be good? What's true about negative 1.97? It's close to freaking negative 2, and that's what we just said a minute ago. It only is going to work well for things that are close to negative 2. Could that be why I picked that? Alright, so then if you just plug negative 1.97 into here, you'll get a number. And how do you check to make sure it's good? Compare it to natural log of 1.03 in your calculator, yeah? The thing I want you to realize, can you guys do negative 1.97 plus 2? What's 2 minus $1.97?
3 cents.
What's 2 minus $1.97? 0.03, 3 cents, yes? 0.03. We could do that without the aid of anything, yes? And then you can compare that to natural log of 1.03 in your calculator, and I think you get like 0.029 something. That's so close, yes? Government work, that's actually too close. We'd have to like push it away a little bit, just so keep our margins better. Might take the humor, I'm sorry. Okay. Is that okay?
Sorry, so I couldn't get that last step about how to approximate.
So you help me out with like, you get the x value, right? Then you can plug it into this, because what's this guy's job? What's this guy's job? That's a good question. What is this guy's job? What does he exist for? Why did we conjure him? What does he do? You're all like, dude, what the hell? Just give me something to think the derivative of, man. What does he do? What does x plus 2 do? Relative to the natural log we started with. What's he do? Finding
Your equation tangent.
that is the tangent line.
Equation.
No, this is the tangent line at the point negative 2. It totally is. But this guy's job is to give me answers that are close to what the original function would have given me. Yes? X plus 2 will give me answers that are really close to what natural log of x plus 3 would have given me as long as my inputs are close to negative 2. Would you all agree that x plus 2 is a much nicer function than the natural log of x plus 3?
Yes.
Would you all agree that a computer would probably be able to crunch 1 billion of these much faster than 1 billion of those? Do you all understand what I'm saying? Even if you don't know shit about computers, do you all agree that evaluating natural logs probably involves more work on the computer's part?
Yeah.
Do you all agree? Okay. So, when it doesn't matter that you're perfectly right, when you just have to be close, tangent lines give you so much ass. Because lines are some of the best stupid little functions that exist. To me, when I learned this, I was blown away at how well this works. It's just dumb. Okay, I'll stop. Okay, let's do this. I'm gonna do something different. This is gonna probably drive me insane. Can anybody pick a problem on the practice test that gave you the most trouble, or if you haven't really had time to do the practice test, which ones look the worst?
2B.
2B?
I mean, just, yeah.
Okay. B or not? Who knows?
And then, it's really the only one I have, because I hate.
Anybody else, or do they all look fantastic? Do they all look like, yes, Jeff, give me all of these? Some of you guys are saying yes, which really makes me happy, really. Hoping you're not doing that to make me feel good. Anything else that, this is your time to tell me. Jeff?
4B.
Say again, what?
4B.
4B. Okay.
And then maybe 6B, just because it has that E to the negative X.
6B, I think we talked about that last time, didn't we?
Yeah,
Pretty sure we
probably.
talked about that last time, but yeah.
I've
Okay.
done it a few times, but every time I get.
Gotcha. Okay, so let's do this. Let's start with let's start with this one because it's a little more self-contained. Who said 4B? Okay. I have to go get some. Yeah, I gotta get some. Damn it. All right. Just to spur some conversation, what I'm gonna do is I'm gonna have to run and get some of these. I'm gonna go get some markers, and I'm gonna put some people up on the board to work on some of these problems, and we're all gonna help them, right? Because all of us want everybody else to do well. So give me a moment. I have brought 0 markers for this. But these are okay. So as I'm gone, everybody consider another problem to put up. Yes? I'll do that.
We should do one MBT.
Kind of maybe have stifled some of this when I said you're going to be going up to the board, so maybe nobody else wants to say anything. I'm sorry. You don't have to go to the board if you don't want to. So let's do this. I want to work on 2 problems simultaneously. So I want to work on 4B. Is that on? Yeah. 4B. Who's brave enough? Ezekiel, I'm going to have people here, just to let you know. And you want to, yeah, come on, it's ours. Everybody's going to help. Who else would like to come over here and work on this? Anybody? Manly's not raising it. You want me to pick some? Which color? You like that color? That color makes sense. Okay. Let's see. Can somebody help? Okay, okay. And then I want 2 people over here, at least 2 people over here. And everybody on that side of the room, keep an eye and help them. Is that pen gonna work? Okay. And then, let's see. I'm pretty sure we did that one last time.
I think we're good.
Yeah, let's do this one. Let me kind of cut that down a bit because that's kind of a long ass problem. Who wants to work on this one. Is that 2B? So what I want you to do is just work on, just work on the first derivative and finding the maximum and stuff like that. Just the first derivative level. I can call a few people out. Does anyone want to try that out? Come on, guys. You can do it. Come on. No? Oh, Joanne. Oh, you kicked so much ass. There you go. Who wants to help Joanne? Just one person. Just one. Just one. Nobody? Jason, get up there. And then everybody over here is going to help.
Board?
Yes, help on the board. Yes, you will? Sure. Okay. Troy's going to get up here and help. And then everybody here kind of help both of them out. I like it. Who said it? Oh, there's one. Okay. Are you guys paying attention? Listen. Ask him questions if you're not sure what he's doing. Is everybody cool with steps he's taking?
The first one, and then, or it's increasing, decreasing.
What do you guys think?
That's what I have. That's
I'll
what I
give a
have.
slight hint, there is one mistake. How are we doing over here?
I
Everybody
don't
see
know
this?
if that's right.
Alright, let's see, what do you guys think?
That's what I have on my.
What do you guys think? Take a look. You guys have no pressure over here. They have all the pressure. Help
Bring
them out.
this down, right?
Verify that looks good.
Then this goes away. And then you gotta subtract this from one, which is seven.
You don't forget the shortcut, -3 minus 7. Put it back over 7, so that works out. Second derivative, does that look okay, everybody?
This one we're gonna bring down here,
Yeah.
and then we're gonna subtract from one, which again
Yeah.
is still number seven.
What do you guys think? Looks good? Oh, you can't see, I'm sorry.
Yeah.
Did I not do?
Yeah, red's not a great choice. Understood.
I can write it bigger.
You're okay. They're both good.
So I'm good, okay.
So focus on the first derivative, make a sign diagram for it. Focus on that for now.
You're okay?
You're okay.
Just-
Can you see this way better?
Oh, first we
No,
have to-
you're in the worst spot, I'm sorry. Did we catch the mistake?
Critical numbers, that's what I said.
Do it again. On which part? Oh, if he wrote it like this, yes. If you wrote like this, you would have to actually do two things. Because then isn't it 2t times? So what would you have to first use?
Yeah,
Product.
it's gonna be zero.
But if he leaves it as it was originally, you could just use quotient. Hell yeah. Yeah. Now, I'll tell you guys this, you ready? Guys, I'll give you one little piece of advice. Do you notice x is being raised? What's the root on x? If you rewrote the fractional power, what root would it be?
7,
7th root. What power would it be?
10.
10th power. Even power.
Even power.
So negative inputs will still come out positive.
Yeah.
You guys see that?
So this is gonna be a plus.
That's key. Then you have less shit to worry about. You don't have to make a mistake plugging your
Wait, no,
calculator.
no.
Careful.
It only alternates on 5.
Okay. Ready?
Because I have trouble.
When you put a negative number in, this part becomes positive times a negative, so that carries negative. When you put a positive 1 in, this is positive times negative,
Get a negative.
still negative.
Negative, negative.
I need you guys to notice the power is even. So when you plug a negative or a positive, it's gonna come out the same. So it doesn't change signs of both. It is related to multiplicity, but it isn't really multiplicity.
11.
If you don't trust me, you got a calculator, you can plug things into the function, get numbers out, and see if it's positive or negative. kick ass. Alright. And do they have the right letter on their sign diagram? Okay, there we go. That's good. So who are the candidates you're putting into the contest? You're like, should you? So I always look at this as, you got a list of
Critical
questions, so
numbers
who are you gonna
zero
check?
only.
You're gonna check
Number of it.
negative 11 and,
He said 0 and
no,
Yeah.
no. One of those is not allowed in the contest, because it's
Even.
negative. Yes.
So the negative,
Can't be more than
even
half a
with the
second over
negative
here.
base.
I mean, negative
it's
11 is
all
not, it's
negative.
bad.
Can we put it into a fraction?
You guys see that, the one is not.
Well, I just switched this
So I
from
can just forget about it.
fraction,
Not allowed in
actually,
the
it would have
contest.
been.
That's what I'm saying for the next differentiation.
So you can see what its power was.
It's a negative power. So it would move on the bottom. And if the bottom is 0, my function is undefined, so it should be a U up there. So I know something exceptionally weird should happen. So on what intervals is this decreasing? No. What's the one place it's
Oh,
not
at-
increasing or decreasing?
At 0.
At 0. So what intervals is this decreasing on?
Negative
Negative 50 to 0.
And 0.
Kick ass.
And where's the bracket?
No brackets.
Oh, it's just,
Yeah.
that's what I messed up on my.
You'll never put brackets for a question about increase or decrease, because the point you're stopping at, you're stopping because either it's 0 there, which means it's not going up or down, or it's undefined there, which means it's not even doing something normal.
Alright,
Yeah.
so it would be the interval.
I like that.
Increasing and decreasing. Decreasing, right? Yeah.
That's roughly, negative 0.16. Somebody check me. I think it's
Not technically.
probably more.
This one?
118? Okay, that's close enough.
Increasing at 0 or 0?
It'll be 1/4 plus 1.
So it's not increasing.
This is a part of it.
So it's kind of funny.
So it's gonna be the same.
So when you add 1, we can use the trick we learned. 1 plus 4 is 5. Put it back over 4. What's 1 over 5 force? 1 over 5 force is.
I just do that so we can, so
Plus
this is
3
an odd,
get 0 to this.
so it's gonna go
Roughly,
back.
which is not, which is the point.
Negative.
So it is, just to make it easy.
So our line is.
So now you just tell me who won the highest contest and who won the lowest contest. Oh, no. So, sorry, real quick. At 0, ain't doing shit. At 0, it's just freaking out. So don't even put that. It's not increasing anyway.
Okay.
Yeah.
It's just undefined as 0.
Yes.
So would you write undefined as 0 or just?
No. Your little U does that.
Oh,
Yes.
Was that technically an asymptote? Because the curve of this one.
Yeah, this will have an asymptote because
I just can't remember if we technically called
F
it.
of 0 is undefined. So
Okay.
something's gonna happen.
That's just what I wanted to check.
All right, guys, thank you. You guys can sit down.
do we need to do a line?
We will.
Okay.
Now, what I really want is, so guys, how's this going so far? Do you see how, I understand if you don't wanna go to the board, I understand that. You see how it doesn't matter? Everybody's here to help, yes? Can somebody come up and do the second part to this, which is analyze the second derivative? By the way, did you guys find any maxes or mins? Did you guys find any maxes or mins?
No, we just.
Okay,
have
good, you're good.
The 0.
Okay. Anybody wanna do? If not, we'll just go back to me staring at you saying, what do you want to do? Anybody? Yes, Samaj? Okay, Samaj? Oh.
So they're.
I do, it's just a question of where I put them. Oh, they're over there. Yes? Okay, so what I want you to do is do the same thing they did, but for the second version. How are we doing over here? Okay, yeah, so let's see. Alright, so I got an absolute min and an absolute max. Yeah, there's only one positive one, and it's that easy. Okay. Yeah. Okay. What was the, oh. I don't know, do you guys, I'm pretty sure we did this one last time, but does anyone want to, or maybe I'm
I
thinking about,
worked it, but I don't know. if
you've
I
already been up,
did it right.
John, so, where'd my,
I'll
oh, that's
tell you
right,
if we
I don't
did
have
it
enough
last
pens.
time. Where's my notes?
Oh, as soon as, Jose, you're done. Where's my pen from over there? Thanks, man. You're good, you're good. Oh, good, I got a big ass board right here.
I don't have it for in-class notes though. Oh, it might be here, hold on.
So, you're trepidatious to go to one of the sideboards. I know if I come up to the front board, everybody's gonna wanna come up here. Does somebody wanna try 6B out here?
We did the limit of 1 over x minus 1 e to the x minus 1.
Alright, Lucky's gonna try. Lucky, as you do each step, I want you to let people here know what's happening.
We did this one in class.
What's up?
I said we did this one in class.
Oh, yeah, that's from a while back.
That's-
But I mean, recently, I might be thinking about somebody asking me about that.
I probably asked you about it in.
over here? So now, real quick, you guys see what's changed? What was the fundamental thing before you did a sign diagram of that I put in? The fact that the power was. No, the power was even. Yes, it's 10, right? And that's why the sign did not change. What's our power now?
We should
Our
do
root's
one
still
means
7.
value
What's our
there.
power? No, it was odd, right? So now our sign's gonna change. So, let's see. If you put a positive 1 in, what's 1 to any power? 1 times positive blah 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 is positive. Put it up here. And therefore, put a negative value in. 7th root is still negative. 17th power, still negative, correct? You guys with me? Because it's an odd power, it maintains the sign. Times positive is gonna be negative, and we already.
Oh, you're doing the.
Since the multiplicity is odd, again, this isn't straight multiplicity, but it's power multiplicity. I know it's gonna change signs. So what's happening back here? Considering this is the second derivative, what's true back here?
Oh, yeah.
Concave down, so can you draw an example of that underneath? Sad, I like it. Perfect. And on the other side, it's concave up, very happy. Okay. So do we have an inflection point?
Yeah.
Not really. Concavity does change at 0, correct? But the problem is, what happens when you try to plug a 0? You get none. You get 0 to a negative power, so you get 1 over e to the 0, which is
Undefined.
Yes. You guys with me? You gotta pay attention. If the power's negative, it actually flips everything. And originally, if you look at the original function, the way it was written, it's 1 over cube root of, 7 root of blah blah blah, right? So, okay. So it does change concavity, but that's a value that doesn't lead to a point because it makes the function freak out. So there's gonna be an asymptote.
Some kind of
And we've seen concavities change.
So we're
What kind of concavity is this?
You're squaring the infinity.
What kind of concavity is this? That's concave up. What kind of cavity is this? Yeah, that, and isn't there like a asymptote in the
Do it
middle?
again.
You with me? You've already seen concave down becoming concave up around its undefined point. You've seen that. You've seen a function that does that. Now we're seeing it in real time here. It's got a point that makes it freak out, but it is around which the concavity does change. We've seen this shit.
Times 2, right?
So we actually kind of know what this looks like. What do you think? Sorry. Yes. Yes. Concave down, concave up.
This would go to 0 because e to the x squared is infinity.
So guys, how are we doing up here?
From here is just 2.
What's good about this step here?
Thing.
You could potentially use L'Hopital's if you show like they did. Always put parentheses around this, by the way.
Oh, parentheses.
Yeah, because otherwise you're saying, I can do this. But now we're saying it's in this form, and that's okay. Never plug infinity into something. Oh, huh? You can't. You have to get there first to get it, and then you can shove it in somewhere. You can't do it. Alright. Except in Pulp Fiction, where I think that's what they had in the previous. Somebody made it there, shoved it in, closed it. So, just to point out, Lucky made a ratio, and you might have already said this, I'm sorry, I wasn't.
Oh, you're good.
Lucky made a ratio, saw that it was indeterminate, so that immediately means you could use
L'Hopital's.
old French dude, yes. Although he is probably young, because everybody died young back in the day.
That gives you negative infinity over negative infinity, right?
Yeah, so infinity over infinity, and then L'Hopital's, and it's still infinity over infinity. So one more application of L'Hopital's, and you get something that's determinate.
2 times 2.
Well, I mean, what's the answer?
4.
Yes, because it's 2 divided by really big. I think I told you a story about the one student who kept putting infinity in, and I told them, don't just put BFN. So like, I had them write, they would write 2 over infinity,
That's
and
how
that
I
drove me
did it.
insane.
That's how I did
And I
it.
told them, no, put that, 2 over a big freaking number is 0, yes. Because they just wouldn't stop. They couldn't stop, wouldn't stop. I'm like, you're gonna stop. Okay, maybe. Okay, maybe. I really want you to notice, we can write this because it's talking about the form it's in. It's not work, it's not answer, it's form. So there's nothing wrong with writing this. But the minute you write something like 2 over infinity, now somehow you got to infinity, you picked it up and you shoved it in. You can't do that shit. That'd be neat if you could. Shove it into an engine of a car and see what happens. Look at infinity! What's up? Shove it into a police box, you got TARDIS. Maybe that's how it works. Okay, maybe. Is that okay? That kind of brought everybody to life a little bit. Instead of just Jeff up here going, does everybody have a good? Alright, want to do one more like this or no? Is there another one you want to point out? If you point it out, you don't have to go to the board. Yes? In case that's what's keeping people back. Is there another problem you want to do in this way? Or do you want to transition to some other thing? Any other problem?
BF5.
Which one?
The MBT problem.
This one? Oh yeah, it's a good one. It's, okay, we can look at this one. Who's
Well, that-
not been to the board but that would be willing to come to the board to do this? Anyway. Who? I'm sorry, I'm missing something?
Did I just
No. It looks a lot like that one. You did the absolute value, the absolute true value. This is the mean value.
okay.
I'm with you. Let's say it was like, you're not gonna stop it. Should I sign my work, Jeff, so you don't steal it? I'm like, I'm sorry, man.
This been through the same process, but
It's a
I mean, it's not surprising that a lot of things involve derivatives. Because how much calculus have we really learned? Now, to be honest, we've done a lot of shit, yes? Y'all agree we've done a lot in here? But it's all been based on one calculus idea, derivatives, yes? The limits we're building up to developing derivatives. Once we learn derivatives, we learn all the rules, but it's all just a derivative. So of course, we're gonna see most problems involve at some point freaking taking a derivative, because that's the only calculus we know. Anybody feel like coming up and doing part B there? Okay, that's fine. Can you guys help me out then? Let me see. Here, I'll do it over here, so I can get it on the video. Well, by the way, I should probably walk around the room. Yes, that might be good. What's the mean value theorem all about?
You have to have continuous and differential.
Okay. Does anyone remember anything about this kind of function? First off, what kind of function is this? Yes, and the way you piece this together is, isn't it a ratio of two polynomials?
Yeah.
So it's a rational function, because that's why we call them rational functions, because they're ratios. What do we know about rational functions? Are they continuous and differentiable everywhere? Yes, good. They're continuous and differentiable everywhere on their domain. What is not in this guy's domain? So x can't be 1. Does this interval include 1?
No.
So is this continuous and differentiable on the interval? There. Okay, so this is continuous and differentiable on blah, blah. And the differentiable would be an open set, but I'm not going to get that big. So bear with me. Okay. Does anyone remember how to just say mean value theorem in English? What is the point of mean value theorem besides giving you more problems to remember? No.
Where is the derivative the same as the slope from the
Average slope.
Oh, okay. It's kind of like calculus equals algebra, right? It's as the crow flies from one point to another, and there must be at least one place where the derivative has the same value. Is that right? So visually, it's just, here's the algebra slope, and then at least one time, it's got parallel slopes, if I look at it calculus-wise. So calculus equals algebra. That's basically mean value theorem. Is that okay? If you categorize it in your head, you'll know the two things you have to do. What are the points that I need to use to do the algebra? My y2 minus 1. How do I get the points I need for the algebra?
Plug the x values in.
Do the who to what? Where if I put my glasses? Oh, there. Alright. So how do I get my points? I'm sorry? Say it
Plug
again.
the x values into the function.
Yes, so I got two x values that are most important here, right? What are the two x values?
-3 and 2.
Good, because they're related to my endpoints. So if I plug a -3 in, I'll get a point for that. What do I get when I put a -3 in? Oh shit. What do I get on the top? What do I get on the top?
-6.
-6. What do I get on the bottom? -4. -6 over -4 is 6 over 4 is 3 over 2. Okay. I'm just plugging shit in your calculator. Stop. When I plug a 0 in, what do I get? Better not plug a damn thing in your calculator.
0.
0. You would, I mean, you get 0 over 0 minus 1. 0 over anything except 0 is 0. Can you find the slope between those 2 points?
Yeah.
And I can't remember, I think the book makes it sound much more complicated than it is.
They use
does.
F
Like
primacy.
almost everything. This is all it is. Find your 2 points and then live in algebra for a little bit. And now I'm almost certain you guys are like, man, I remember those days. I thought it was terrible, man, I miss them. Maybe? I don't know. So, find a slope. Now, is anybody concerned about the fact that there is a fraction in there? Some of you guys. Can you guys tell me? If I have 5 chairs and divide them by 5, what do I have? 5 chairs divided by 5. 1 chair, yes? If I have 5 people and 5 chairs, how much does each person get? 1 chair. So if I have 5/7 divided by 5, what's that? 5/7 divided by 5. 1/7. Same idea, yes? 5 anythings divided by 5 is 1 thing. So 3/2 divided by, let's see if you guys are with me. This is going to be 3/2 minus 0, right? Y2 minus Y1 over X2 minus X1. What is 3/2 divided by 3? 3/2 divided by 3 is 1/2, and there's a
Negative.
negative. We're better than that. We're humans. We made this shit. It works for us. Try to plug in a calculator, you can really get yourself turned around. You might not plug it in correctly. It'll spit an answer out this number. We're better than that. So that is what? What did we just calculate? What the hell is that?
That is the,
Good. That's the algebraic slope. Now we have to do the calculus slope. And how do I do that? Yes. I think I'm rubbing off on you the wrong way. Where's the rubber? Okay. Alright, I'm not gonna let you guys do that. If you want to do this, I'll give you a couple minutes. Can you guys do the first derivative of that real quick? You know, like define quick. Slow your roll, Jeff. By the way, if you go into the Sissel, I think I've said something like this to you, but I don't have all the time in the world, and I wish I did, to address every potential prerequisite skill we've forgotten or haven't done in forever, you know? If we hit a problem, you're like, I don't know how this man just did this shit, and it's supposed to be, I don't know what the hell's going on. And you don't ask me or whatever, just ask them. That's part of the reason they're there. The main reason for the Sissel was originally a place to practice prerequisite skills. And then we realized, no, people are gonna come here with specific current problems, so we have to do kind of both. But don't forget, you can go in there and go, listen, I'm in calculus, but I have a lot of problem with this. I don't understand what happened here. And they will help you, they will give you resources. Do you guys understand? I will too. I can't do that in class all the time because I have to get through the calculus. Yes. Okay. All right, let me catch up to you guys. Top first. And the derivative of the bottom is
squared by x minus 1 squared.
derivative of the bottom is
Oh,
1. Good, so this is times 1, yes? Derivative of the top times the bottom minus derivative of the bottom times the top, all over bottom squared. 2x minus 2x is 0, and I get negative 2. What's the critical?
It's gonna be positive 1. Oh, wait.
Actually, not a critical number, I just forgot what the hell we're doing. What do I do with that now? That suddenly was then a different problem. No, that's where I gotta be careful even myself. For a moment, I just forgot what the hell we're doing. Yes, so we have slope from algebra, we have slope from calculus. They both represent the same thing, so I'm gonna set them equal to each other. All right? I wanna see where the slope between the endpoints is the same as the slope on the function itself. If I have a continuous differentiable function, it has to turn back and have the same slope at some point. It's not allowed to do this. It's not allowed to teleport. Because it's got to be continuous and differential. Which is why, on one level, it's kind of simple. You should be like, well, of course this happens. It's not allowed to get away from. So it's not to. If it goes away, it's got to come back, and the minute it turns, it's parallel. Okay. Now, here's the thing I was just talking about. And then I completely forgot why I said it. I knew we were going to end up here. Do you guys know how to solve that? Oh, it's right on.
I'll get it on.
Oh,
I have our notes page.
Do you guys know how to solve this? I mean, yes, you do. You know how to solve this. Yeah, cross multiply. This is the one place cross multiplication actually directly works. And it's the one place people end up not doing it or something. People do it in all the weirdest times. I'm like, no. But then you just cross multiply. Yeah. Do not square x minus 1. You'll see why in a minute. What do I get here, man?
-4.
-4 equals
X minus 1.
negative x minus 1 squared, right? So the negatives go away. Are you guys cool with that? Now, do you see why I don't want to FOIL out x minus 1 squared? Because what can I do right now? Why can't I just solve for x? What's in my way? If only it wasn't there, I could add 1 and be done.
The power.
What's there that I wish wasn't there?
Square.
Stupid square. Okay, what do I do to kill it?
Square.
Square root. So remember, when you're in an equation, say to yourself what you don't like in it, and then think, can I kill it? There's a ton of shit we can do when we have an equation to kill what I don't like. Now, again, wait a little side note. Not a life lesson, kids. In general, don't kill what you don't like. Please? Thank you. In math, it's fine. These guys love that shit. For these guys, existence is pain. So if you kill them, they're really happy. They're just like Mises. So if I square root both sides, what do I have to be careful about?
Plus or minus.
Plus or minus. Square root of 4 is 2. That's crazy. Here, the square and the square kill each other, yes? Do you guys see how I get 2 answers? Okay. Don't come up to me and say, where's my plus or minus key on the calculator? No. You're going to add 1 to 2, and you're going to add 1 to -2. So you guys see that? Okay. And then you get 2 answers, and I think only one of them's in the
In the domain.
interval. Forgot what the hell it was. Oh, there we go. So x minus, just to make it really clear, x minus 1 equals positive 2, x minus 1 equals -2, x equals 3, or x equals -1. 3 is not, we started way up here. 3 is not in here. Screw you. This one is. That's where things happen. That's where the function turns and becomes parallel to that algebra slope, that straight drive you could take. Okay. Especially here in San Diego, there's a ton of these canyons that you just have a street stop and pick up. So you have to turn just to get over there. Yes? You have to turn, and then you turn back, and then at some point you're like parallel to where you would have been going if you would have been allowed to just go straight. That's what this is. This is what would happen if I could just go straight. The street goes like this because it's a big freaking canyon, but at some point I'm going to be parallel to where I would have been going in the first place. That's that. That's what I mean by azerotrophos. Maybe? It's a beautiful physical idea. And it's using old and new math. I love it. You would, Jeff. Okay. Well, I have a second. Did anybody not get their quiz from earlier? Anybody come in after? Oh, Bailey. Luke. Who else? Oh. Are you Sergio? You're old. Is that everybody? Everybody? So, quizzes for people that came in after I passed them back.
I'm doing correctly the quiz. Right now,
Yeah, you always, the end ones who could happen are the critical numbers that are in this. So once you get all the critical numbers, plug them into the long end ones into the original function, just need wins. Any critical numbers that aren't in between 0 and 4, you can forget, because they're not allowed in the contest. Yep.
Are you able to do that on a board market? It's another sign. They want us to graph this.
Oh, okay. I'll tell you this though, I'm sorry, while I'm thinking about it, do I still have all that work up there? Over there, yeah. Here, we'll do that right after this. This problem here, on the answer key, I didn't graph it, I said we'd do it in class. These two? So let's see, let's look at 2A. I'm gonna accumulate everything we know about 2A. Let's see. Where am I at? Oh, here we go. Oh yeah, that's right. So 2A, I'll just cut to the chase here. For F prime, I got critical numbers x equals 0 and 3. And then for the sign diagram, here, I'll tell you what. I'm going to pass out this, the answer key, so you guys can kind of follow along. It's 2 pages, so keep what I give you. Always skip Joanne, and then she's in. Then I sat in the front, so I get up first. But
Oh no, I stood up here so I could see.
no, that's a good point too. But that's a fringe benefit supposed to be.
Yeah?
Not yet, not yet. Not yet.
Well, don't give it to you. Sure.
Five A, you said?
Okay. We're looking at 2A right now.
I was gonna say that again. Five A, okay. I got it.
So let me say this. So you guys can see the first derivative. I'm just going to collect all the stuff I did, so I'm not going to redo it. So you guys can see, if you didn't do this problem yet, what I got for F. I'm going to focus on F. So I got, I got minimum at 3, -12. I got inflection points at 0, 15, and 2, -1. I got, you could do it, Jeff. Oh yeah, this one's evil. Okay, I didn't quite mean this one to be so evil. I keep forgetting to change this. But there's no way to solve for the x-intercepts algebraically. But notice along the way, do you see how close, when I plug a 2 in, how close it got to being 0? So there's an x-intercept between, where'd it go? You can do it, Jeff. Between 2 and 4, there's an x-intercept. I think I just kind of gave up there. It's too bad, Jeff. X-intercepts between 2 and 4. And there's another x-intercept close to 4, if I remember correctly. Okay, we'll see. What else do we know? Anything else? No. So if I want to graph this thing, oh yeah, we need that too. Let me see. F prime look like this. Where'd you go, Jeff? There it is. Negative, negative, positive, and F double prime look like this. Positive, negative, positive. Good job, Jeff. So it's up, down, up. There's, yeah, okay. And that's why there's inflection points at 0 and 2. So if I want to graph this thing, my outputs seem to be like 12, 15. So let's see, I can go by 3s maybe.
Does it say the graphic?
Yes. Part 6 says graphic. Well, it says,
Doesn't
yeah,
it?
plot.
Oh, plot.
Graph, yes, it does say graph.
Oh, find and plot, I see it.
And then it says, and then graph. But my X inputs are pretty, bless you, pretty small, so I don't have to get too crazy with Jeff. What are you doing, buddy? You feeling all right? Okay, so we got 0, 15. 2, negative 1. 3, negative 12 is a min. So 2, negative 1 is an inflection point. These are inflection points. 3, where'd it go? 3, negative 12. That is a min. Oh boy, this is looking, this is a mess. Okay. These aren't points, these are like mistakes I made. Okay, good job, good job. Looking great, looking great. So there's obviously gonna be somewhere it goes through the x-axis here. Since that's a min, it's gotta turn and go through the x-axis down. Okay. So it's decreasing concave up. I didn't give myself enough room back here, that's too bad for me, but decreasing concave up, and then there's an inflection point here. Okay, let me stop for a minute. You guys with me? So how do I get things started? I see that it's decreasing to start with, and it's concave up. So I know I'm coming at that inflection point like that side of the parabola, yes? Then I hit the inflection point, so what's gonna happen now? I'm gonna switch to being concave down. So now every point's gonna tell me what to do next. I know I've gotta hit the next point, and when I hit it, it tells me what to do next. So now I'm gonna be concave down until I get to this point, at which point I become concave up. And what I normally do then is I start here, just to really, really overdo the concavity. There. And then you can check it on a calculator. Now that problem specifically, I didn't make a problem where you could find the x-intercept easy, so I'm cool with you just kind of like going through it somewhere. You can't find it algebraically. You can't even find it synthetically. This is gross. Okay. Bless you. So really, you're not just labeling things for me. You're labeling them so that when you hit it, you're like, oh, now I changed concavity. I see the next point I've got to get to. Let me keep going. Now that's the min, I know I've got to turn. Do you see what I'm saying? Okay. So what about the other one? Let me give myself some more room this time. Has everybody got that? That wants it? No?
I have it on paper.
I'm gonna do this. I'm gonna accumulate what I know about the second one, which is not much. Okay. What else do I know here? Let's. Oh. No y-intercept. Okay.
I see just the top of that, what you have under IP element. About that, okay. Critical number.
So here I've accumulated what we know about G. Right, this I think matches with the stuff on the board over there, so good job, guys. No max or min. There is a place where concavity changes, but the place where it changes is itself an asymptote. So there's no inflection point. So concavity can change around inflection points or around asymptotes. Everything can change around asymptotes because there's freaky places. No y-intercept, which makes sense because the asymptote is at x equals 0. It's on the y-axis, so it can't hit the y-axis by definition. So, if I go to graph this, I've got an asymptote here. I've got a single intercept there. Did I say some other points? I did say some other points. That might help us. Does anyone know, let's see, where'd it go? Yeah, let me look at it this way. I don't think I even said this on the thing, but the function was this. What happens when x gets really, really big? What happens when x gets really big?
So it gets smaller.
That one piece gets closer to 0, so the whole function gets closer to 1. So what does that mean is happening at y equals 1? Oh, you could do it, Jeff.
Closer to 0.
So the limit is 1. So what is that? What's that the location of? As x gets really big, so at the ends, this function has to approach
Infinity.
1. When x gets really big, 1 divided by big is small. In the limit, it's 0, plus 1 is 1. There is a asymptote of 1.
1.
So then I know this has got to look like this. And that's got to be concave down, right? And decreasing. In fact, it's decreasing everywhere. So on its face, that might freak you out when you first see it. It's decreasing everywhere. But it's because when it starts over again, it's decreasing it. Now, how do I know it's up here? What would it have to happen in order for it to be down here? 2 things. It would have to be concave
Up. Oh, no, down.
down, but it's supposed to be concave up, correct? Also, it would need to have a x-intercept, and it don't, so I know it's up here. Now it's concave up, and it's on the side that it's allowed to exist on, which is a good idea. Okay, maybe? Maybe, Jeff? Screw you. Okay. So with the fact that the function originally had this piece on the bottom, I know there's going to be some asymptotic behavior. There's going to be values that make it freak out, potentially values that it has to approach. Okay. And that explains, do you all agree that that is constantly decreasing? Because it's decreasing forever, and then it starts over up here, and then it's decreasing forever from there. It's crazy. So it's like Escher steps. They're always going down. Anyway, I don't know if you've ever seen Escher steps. Okay. Alright, that's the one thing that I didn't do on the practice test, because I thought it would be easier if we did it live to see what goes into putting the thing together. Alright, so is there anything we haven't talked about yet? Could be from the quiz, homework, general ideas. Do you see something on the practice test that you have no idea what the hell I did? Do they do all the problems? I really hope so. Yeah, you guys see, like, the second page is all the optimization problems. I didn't give you a ton to overload you because you never have to do any of the practice tests. I gave you tons so you could pick and choose. The last two I think were kind of challenging. So I probably will put one optimization bonus problem. So there will be some more basic ones you have to do in the actual test itself. Yes.
Over 6A.
What is 6A? Oh yeah, look at that thing. Okay. So what's the very first thing you try to do whenever I give you a limit problem? You know there's a good chance, I'm not going to say I definitely will, there's a good chance it's going to give you a limit where if you just plug it in, you're done, right? Well, if you try to plug 0 in, what do you get on the top?
0.
Good, natural log of 1 is 0. Tangent of 0 is 0. 0 over 0 is indeterminate. And why am I allowed to apply L'Hopital's rule directly? There's already a ratio that's indeterminate. That's exactly when L'Hopital's applies. Okay? So then you do L'Hopital's. Now, the algebra part of this could get gross. Yeah. So what's the derivative of the top?
1 over 1 plus 1.
And what's the derivative of the bottom?
Secant squared. Pi
Times?
times
Pi. Good. What rule did that come from?
chain.
Chain. Got to take the derivative of the inside at the end, right? Derivative of the inside is pi.
Does that just end up equaling 1 over pi?
Yeah. That's the beauty of this. There's no simplification to do. In fact, if I were you, instead of trying to like simplify it, I would just try to plug 0 in now. Maybe so the top becomes 1, right?
Yeah.
And the bottom becomes just pi.
Pi.
You guys see that? What's cosine of 0? 1. So what's secant of 0? 1. So then pi times 1 is pi, 1 over pi. I like it. The reciprocal of pi. I'm not sure what that would be in real life.
0.318.
Reciprocal of pi whipped cream. Come on! Crazy shit. Do you know how to check that? If you graph it and then trace, get really close to 0, you'll get some decimals. Then compare that to 1 over pi. That's how you check it. Because what's the point of this? This is saying when you let the input get close to 0, your output should get close to 1 over pi. So you can do 1 divided by pi first, see what the hell that is, right? And then trace the graph and see if you get close to that decimal, right? Or don't. You don't have to do that, it's just if you have time. Why would I, even if I wanted to, why can't I use L'Hopital's on this? Nope, I did not use L'Hôpital's on this. I used L'Hôpital's on this to get here. Why can't I use L'Hôpital's again?
Yeah, so that's what I meant.
It's not indeterminate.
It's not indeterminate anymore, and the only time L'Hôpital's rule is guaranteed to work is if it's indeterminate. You could get lucky and it could still work.
You just do more just
Yeah. It's kind of dumb to keep going if you're like, just stop, and you get the answer. But people kind of get that, like, just keep doing L'Hôpital's until you get like a nice, and you're like, no, you can't even, no, you're not even allowed to do that. And this would never get to something nice. Do you guys have zero optimization questions? Is that because you guys are like,
Don't know.
I'm gonna focus on everything else, and then this man's only gonna give me like one optimization problem, so I've run the numbers, Jeff. I think I can just skip that, and I'll be okay. Does anyone ever think like that? I really hope not. But I understand from a practical standpoint, I understand like, well, you might.
What's the big takeaway when we're looking at an optimization? Just so when we get to the test, we know what to.
So when you say big takeaway, do you mean like what's gonna tell you that that's what it
How do
is?
you know what to look for exactly in the question?
You look for a word that means make this the most or make this the least. So they could say something as direct as, I'm gonna maximize the area, and they're like, okay, just gave that shit away. Because that's the definition word, the derivative word, so like max mid. But if they say, I wanna find the closest, okay, that's distance, make it small, minimize the distance. If you identify that, then you go, oh, I eventually need a distance formula so I can attack it with calculus, yes? If they say I want to give my cows the most room to roam, oh, maximize the area. Okay, so then I need an area function so I can attack it with calculus. Do you see what I'm
Let's
saying?
do number 56.
56? Where was this? Did I get my stuff out of 47?
344.
Thank you. Ooh, yeah, that's a good one. Oh, yeah. All right, this one I would say is probably, it's a little more than one I would give you straight. It's a little less than a bonus question, but it's definitely a little more than one you would get. But still, I love the outcome to this problem. Do you guys get the idea of the problem? This is kind of a silly thing if you're like standing there and you're like, I gotta get over there as quick as I can. You're not gonna stop and go, let me calculate what's the best. No, because then you're wasting time, you're gonna do it. But if I knew ahead of time, okay, they're gonna drop me here, because it's the one place they can drop me. You're a spy, you're an agent. And then I gotta get to that point. Do I wanna swim? Do I wanna run? Do I wanna do a combination? So this person, what does she do slower? She rows the boat slower, correct? For whatever reason. And she walks faster. So it kind of makes sense that I'm not gonna row straight there. Even though that's the shortest distance, that would not become the shortest time. Because that makes sense. And we've all experienced this in California. There's a certain time of day, you're not necessarily going to go the route that's the shortest distance. You're going to go the route that's the shortest time, which very often is not the shortest distance. You guys with me?
Yeah.
I've gotten some funky ass routes.
Intuitively, you can tell, like, because in order for her to arrive at the same time, it be like the not straight route, the A to B, would have to be like half the distance for her.
Oh, I see what you're trying to do.
You know,
It's not a bad idea what you're trying to do. I think it's a little tricky.
I mean, I'm just kind of trying to intuitively, it makes like yeah, you can tell pretty obviously that walking will be faster. If you're
Yes.
going to say
So, listen, she could row all the way. Are we all agreed that that's probably not a good idea? She could walk all the way. Does that sound like it's a good idea? Or she could row to a point and then walk the rest of the way.
intuitively, that feels like something that would probably be best. So she could cut off some distance, but also do more the quicker way she can move. Right? Does that make sense?
Oh, I get it, yeah.
So that's possible. Let me stop for a minute.
Didn't they imply that it's not, oh wait, yeah.
Now, one big reason I would not make this a test question is because I don't know if you guys remember, what distances do you have to know how to get?
Area.
How do you get that distance? Yeah, and then how do you get this distance?
Theta.
That's kind of tricky. Circle math. That's not an interior, that's not essential angle. Do you remember what they call it exterior angle? But does anyone remember the relationship between, okay, real quick, okay, several things. This problem is probably too much to give you out of nowhere. Do you guys remember, if I did know this angle, I'm gonna call it alpha. Do you guys, Jeff, you could do better, buddy. There you go, connect the dots. If I call it alpha, do you guys know what distance this is?
A radian.
Do it?
Radians.
No. What distance is it?
It's the length of the arc.
The length of the arc. You guys remember arc length? S equals
R times theta.
R theta. So in this case, this would be 2 alpha. Yes? But I got this angle. I don't know this angle. No? Yes?
Half of
Screw you, Jeff.
It would be
Which angle is bigger?
the theta. Oh wait,
Which angle is bigger?
The
You guys
arc.
could do it.
the arc.
All right, look. I'm looking at the ceiling, yes? And you guys should be able to tell from the picture, but I'm looking at the ceiling. There's an angle here. You guys agree? I gotta move my head by a certain angle. If I get closer, do I move my head by a bigger angle?
Yeah,
Okay. So which angle is bigger?
that one in the middle.
Alpha.
Alpha.
Does anyone remember how much bigger it is? Twice.
2 R.
Yeah, twice as big. So which means, in terms of theta, this will be 4 theta. 2 alphas is the same thing as 4 thetas, because alpha is twice as big as theta. All right, so that's number 1. And I'm almost certain a lot of us don't remember that. Secondly is, how do I get this here? Well, one thing to realize is this neat thing.
You got a triangle.
This, oh shit, how do I draw this without, as a writing?
So that's when.
This is 4,
That's
and
when
that, what is this? This is the what of the triangle?
The
Yes? Yes?
opposite.
Yes? No? No?
The hypotenuse.
Hypotenuse, the hypotenuse, yes.
And so that's your J.
I love you guys so much. That's 4 cosine theta, just to cut to the chase. For the angle in the base, this the x side, cosine likes x, that's 4 cosine theta. And then, so now watch, okay. You guys, I don't blame you if you've sort of tuned out. I don't want to focus on this too much. What formula do I need to set up to attack with calculus? This is what they tell us, by the way. What do they ask me? What formula do I need to set up? You can do it. What formula what do I want to minimize or maximize or what?
Area. Distance.
Nope.
How should she proceed? Can walk. Oh, shortest.
See how that word is important? That's what you were talking about earlier. How do I tell when it's this kind of problem? Well, number 1, what kind of word problems we're going to have on this? Yeah, so if it's a word problem on this test, it's optimization. On the final, you're going to want to know what to look for. Shortest, okay, optimization. Shortest time. That's the function. I keep saying function, so weird. Because I'm about to say formula and I say function. Function. It's the function I need to set up so I can attack it with calculus. How do I find the maximum or minimum? Good, that's really good. Minimum? Sure, Jeff. How do I find the maximum or the minimum of a given function?
First derivative.
Derivative?
Critical number.
Critical numbers, test them, yes? You with me?
This is that kind of problem, it just didn't tell me the function. It's like, here's information, set it up yourself.
So that would be that 4
So,
cosine.
we
theta.
want the time, yes? Oh, I love this problem. You would, Jeff. What's time? It's wibbly wobbly. No. Distance equals
Hours,
equals
miles per hour.
rate times time. Distance equals rate times time. Do you guys remember Dirk formula? D equals RT.
Yes.
So what's time? Distance divided by rate. Yes? Okay. So how far do I go here?
4 cosine theta.
4 cosine theta divided by the rate. What's she doing here? This is the lake.
Oh, rowing.
Rowing, and she rows at
2
2 miles an hour. Plus, how far is this? 4 theta. What's she doing here?
Running.
Walking, for
at-
some reason.
at-
We gotta get there as soon as possible.
At
But I'll
4
just kinda
miles
stroll.
per hour.
4 miles an hour, and that is time. There's my time function, yes? I used what they told me to set this up, and then I plugged it into what they asked me, yes? And now do I have a function of a single variable? Is time a function of a single variable? Yes, so I can attack it with calculus, yes? Take this guy's derivative, find the critical numbers, and you can pick up on the answer key if you want to from there. Is that okay, Joanne?
Come on.
So that specific problem has got way too many little pieces that you might have forgotten. But I needed to put it, because to give the answer ends up she should walk the entire way. The critical number you find maximizes how long it takes. You guys kind of with me?
Yeah, well, that's not what we want.
So when you find a critical number, it doesn't mean it's gonna be the answer, because it could do the opposite of what you want.
Yeah, you gotta plug it in first.
So the critical number you find makes the time biggest. So then theta goes from 0 to 90. 90 would be start going this way. So it turns out walking the entire way is the best. In which case she could then walk this way if she wanted to, then it doesn't matter. Unless, you know, there's something here, a monster. I'm hungry. Then you should go that way. But that wasn't part of the problem, I'm sorry. That would have changed our time.
You didn't really have, the options are kind of funny.
Alright, I know, I'm sorry, that one was a little evil for me to.
No, I'm just saying, like, the other ones are not, the other options you have is like, number 19.
Yep, 19. Yeah, I think the last two were trippy.
I can't read what 19
19
says.
is a more standard one.
Yeah. I just can't read what it says.
They like these, we make freaking boxes a lot when we do optimization. We make a lot of boxes, we have a lot of farmers doing their thing, like, good lord. Can the farmers make the boxes, can we save some time?
Firebase and an open top.
So 19, can somebody tell me the idea related to what they just tell us?
Three sides.
No, that's what they asked, so. What's the idea related, what do they just tell me? I just know, I just concretely
Yeah.
know.
Perimeter 12, oh no, not a perimeter, area of 12.
You can just say this, I know there's 1,200 square centimeters of material, yes? And you're like, I don't know what that means mathematically, person, but, okay. Square centimeters means it's related to surface area.
Surface area.
Right, so I know the surface, they just tell me the surface area. This is not a formula you memorize. You guys, I'm about to say something weird. Surface area is 3-dimensional perimeter. How do you find the perimeter of any shape? How do you find the perimeter of any shape?
2x times 2y?
No, stop. How do you find the perimeter of any shape?
Oh, x times y. Wait, no, that's area.
Add one. All the sides. Or you just figure how long it is around, yes? You with me? You don't need to ever memorize any perimeter formulas ever. I know you already have one, 2w plus 2l, but you didn't have to memorize that shit. Add the l's and the w's, yeah? Surface area is the same way. So if you draw this, what dimensions does the base have? And how do I know? I'm asking you a question like I don't know, but yes you do. Not numerically, but you know the relationship. The base is what shape? Square. So then what are the dimensions of the base? Do it again? No. Nope, it's a square. So do I have to give both dimensions different letters?
No. they're
No.
all
So
the
what are the
same.
dimensions of the base?
Four, or four,
What are the dimensions of, it's not L and W, it's just X and X. There we go,
X,
thank you.
X.
Right? Whatever this length is, this one is the same. You guys understand what I'm just tracing out the base of it? Yes. Whatever this is the same.
So X squared.
So it's a really good idea, if you currently can't, to find a way to suddenly become able to make, oh shit, I have no room anywhere. Be able to draw that, yes? Just a crappy little box. The base is a square. So I can make the lengths anything I want to as long as they're the same. So we can make an X and X. What's this? No, it's not a cube. I don't know if it's a cube. They didn't say it's a cube.
Height.
Yes, it's H. All I know is the base is square. The height could be anything. What do they tell me about the top?
It's open.
Open. So what is the surface area? What's the area of the base?
2x.
No.
Oh, x squared.
X squared. Good. So
But
the area of the base is X squared. What's the area of each side?
the height times
X
h.
times H, yes. They're all rectangles X by H, yes. And how many of them are there? How many XHs are there?
4.
4. That's surface area. And what is surface area? They tell me.
1200
1200.
centimeters.
That's what they tell me. What do they ask me?
What? Oh, you took the problem down.
What is the average velocity of a latent swallow? No.
What's? Oh my.
What do they ask me in the prompt?
You moved the problem.
I did, I'm sorry. I covered it up.
The largest possible
Yes.
volume.
So they asked me to optimize the volume. Well, what's the volume of this thing?
The volume is. Wait.
What's the volume of a box? That's L by W by H.
Times width times height.
Yes, so what's the volume of this box?
X squared. Right. Plus
No, times H.
times h.
L times width times height. So X times H, X squared H, yes? Okay, so I'm supposed to attack that formula with calculus, but I can't attack that because that makes it seem like X and H can be whatever they want to be. Is that true? Can X and
No.
H be whatever they want to be?
No.
No, but
We
they thought
have-
it was America. No.
So we gotta do the essay first.
So then you have to use what they told me in what they asked me. So I didn't do something, I should be very, they tell me this, they ask me this. I'm always gonna take what they tell me, solve it for a letter, plug it in what they ask me. Doesn't matter which letter I solve for. No, so I get to pick the one that's easiest. You wanna solve for X. Do you even understand what it would take to solve for
Or
X?
X.
You would have to use quadratic formula in creative ways.
Solve
I don't
for
want to. Is it
H?
easier to solve for H?
Yes.
Shit, yeah! It only shows up once and it's to a first power, so that's the real MVP, is that H. You solve for H, then you can plug in what H is, and then you have a volume formula that's a function of X. You can attack it with calculus. Find the critical numbers. Once you get the function, once you do that, use what they tell you in what they ask you, you're back in section 4.1. You're finding critical numbers, you're plugging them in, blah, blah, blah. Maybe? Maybe.
That was one from here, right? That was one from.
From the, test.
What did Past Jeff do? Did Past Jeff do that right? That guy's a weirdo. Did he even do it? Where is it?
No, it's on the bottom, it just lists the page numbers that you should. Oh yeah, you did them on here.
Oh, there it is. Okay.
29.
Look at you go. I did stuff. Good job, Jeff. All right. Maybe. I don't know. You guys, has anyone done any of the optimization problems? Has anyone done any of the optimization problems? Well, shit. Some of you guys have. Right, in the homework. Yeah. Okay, that's what I mean. Like, anybody done 4-7 homework at all yet? Okay, I appreciate the honesty. I was gonna ask if framing it as tell me, ask me is helpful. Because as a student, I know, I am so aware, you read a problem through and you're like, what am I even supposed to focus on here? So I really hope, like, helping you understand how to break it into parts. Focus entirely on what they told you, draw a picture, just think about just that. Then focus entirely on what they asked you, just said. Now use those together, right? So you're not thinking about everything in the problem at once. And I think that's what students do a lot. I think you think you're supposed to, and that's insane. But listen, don't forget, all right? We've already talked about homework and the right way to do it. The right way to do homework is do as much as you can within the time allotted. The wrong way to do homework is to go, I'm gonna finish this, so I ain't gonna do that shit. Go play Outer Worlds 2, which is real cool. If you're right now at a point where you haven't done entire sections, don't do every problem. Make sure you get enough practice in any section left. Yes? Don't finish 4-6 and go, well, I got as much done, I didn't look at 4-7 at all, but come on, test. No, that's not good. Yes?
Yeah, I'm a little, homework is mostly for practice, right?
I mean, yes,
I think.
but you should be turning it in.
Yeah, if we were taking this, if I misread it or something, what I call basically our homework score, I increase 1 at the tests, but otherwise it doesn't count grade as well.
You are maybe blurring the line between my syllabus and somebody else's. I certainly never said that. Yeah. Yeah, no, it definitely didn't say that.
Yeah, it's like, homework is like 4%.
No, they tell you the percentage that homework and quizzes together is.
Right.
Notice they didn't tease out how much homework itself is. It's really weird as a teacher, part of my job is to trick you into doing things that will help you. Which is really weird. Some of you guys don't need that, but I don't know who is at the beginning, so I gotta trick everybody. You guys have anything else you wanna talk about? Yes.
Would we be able to go over 4B?
We did. I think it's still open.
It's over there, yeah.
That is not one?
Yeah, that's right.
So-
And this one is,
Real quick, guys. If you're trying to find the local maximum, what do you have to develop visually eventually?
line.
Local maximum,
You need-
you have to make a sign diagram.
Sign
Yes.
diagram.
You find derivatives, you find the critical numbers, you put them on there, you do the sign diagram. If I want to find the absolute maximum, not only do you not have to do that, don't, because I will take points off if you do. Because that's a part of the whole idea. Absolute maximum just says, who's the biggest, who's the smallest, and where could the biggest and smallest happen? At the endpoints? Or
We're at a
critical points that are in there, yes? So you just find the critical numbers, you plug in all the ones that are in the interval, including the endpoints, and then you just see who wins. So when you see me say find the absolute, just take this and go, oh thank God.
Yeah, that's easy.
I don't have to do a sign here.
and just find the stupid critical numbers, which is relatively easy, and then plug shit in, which is stupid easy. Yes? And then just go, okay, who won? You won that contest, and you won that, and then you just circle the shit. It is possible, it is possible to have ties. You guys with me? So if I do a parabola and I start it here and I end it there, there's a tie for absolute max, yes? So it's not infinite. If I use a trig function, screw it, I can have infinite ties. But I don't necessarily like doing that, just kind of muddies the water a bit, but it is possible to have a tie. No, they're just being abs. So you would say the absolute max value is 7. It just happens to happen in 2 places. Yeah.
7
So
and
the
3 and 7 and negative 3 or something like that.
yeah. So you can talk about an absolute max value, and then you can say, oh, but it happens in 2 different locations. Yeah. So like, if I want to know what's the most profit we can make, so he's like, we can make $15,000 next month. And I'm like, okay, what does it happen? Either we can sell this many widgets or this many widgets, and then we can pick which one is more feasible to get to. Yeah. Because you could have multiple ties, and one of them could be easier to attain in a real life situation. So then you go for that one. Maybe. Yeah, start talking about business. It's really boring. It's a bit more boring than my normal conversation. Yes, sorry. So that's the result from the quotient rule. What's the only way a fraction can be 0? Is if the top is 0. So critical numbers, it's either undefined, the bottom can't be 0, so there's nothing that makes it undefined, or if the top is 0, then you get the derivative is 0, which is critical numbers. Right there. Yeah, Jason. Yeah. No word. Oh, they're there. Is that mine? It's okay. I had it for both of us. Of course. Yeah, I don't know what that one's doing. Oh, but see, you have to have a way to identify between the critical numbers and the test numbers. You see what I mean? So, this is a critical number, correct?
Yes.
This is a test number. I can't tell the difference as the greater. So like above here, you would put Z, yeah.
Oh, okay.
Then that would tell me, okay, because I need to know, you know, what should be down there. Yeah.
Alright, so that's, I need to add one.
But you're doing, oh, you're looking, okay, yeah. So that's the first derivative here, that's the second, so the first derivative is here. So yeah, you do need something back here.
Yeah, need to add something in there, but for the most part, I'm not doing it right now.
Yeah, so that's positive. Where are you putting?
Increasing it positive, right?
Yeah, so that's gonna help me.
Between here and there, I'm increasing as opposed to doing the first time.
Yes. But that is what's gonna tell me how you figured that out. Believe it or not.
Yeah, cause that was negative.
Okay.
Is that right?
I mean, that part's right, yeah. And now if you think about multiplicity, since they're all odd, it's just gonna change signs around every critical number. So I started thinking,
I just put it in there to tell me this is.
in what? Oh, in the original. There should be a key up there, because it makes the derivatives there. Right? What are you doing up there? Yes.
So what is that, does that give me a critical? That's giving me a max and then showing up.
Well, you gotta finish this. Yeah, if this is up and this is down, there's a max. Up to it, down from it, that's a max. Yeah, so that would be 81 would be the max. So down to it, up from it, it must be a location of a minimum. And then you plug it in the function to see.
And then on this guy, cause I just kept rolling on,
Yep.
I have to, so I just put a negative one in here and a one in here.
Well, be careful. If you do that in your calculator, you get 1.73. So to be on this side, you have to put -2. Okay. Yeah, that's why sometimes I'll put -1 billion in, because I don't care about the number output, I just care about the sign output. Oh, wait.
So if they did simplify it here, so if they did simplify.
There you go, you gotta use quadratic. And then you
but I
gotta
still
pick the
get
one
the
that's
same-
actually in there.
But I still get the same answer, am I gonna get things deducted?
For what?
If I just didn't simplify the actual,
No. Yeah, you did even better than me, you showed that, that it is in there. So stop showing me up. Alright guys, see you Wednesday. Huh? Because they want to. It's college. And it's review day, so. Yeah. Oh, I'm sorry. Ask me about this one.
You don't have to draft it, it doesn't matter. Once you take over, I just don't know it.
Oh, this is where you, factor out the smaller column.
Like these are here.
So, and the bottom can't be 0, so there's no undefined critical numbers. So then you set the top equals 0. And if you factor it, then you can set these factors.
Okay.
So you take out the smaller power. The way derivatives work, when you do that, it always makes one of them become a whole it. You see it like 1/2 minus -1/2 is a whole it? Yeah. So it's neat how that just sort of sets that up. Yes.
Two things. One, I'd like you to help me walk through one of these, and I'm ready for the answer.
Oh. By the way, guys, it's kind of funny what I'm about to tell you. I don't know if the spring schedule's out. So I am teaching a Math 280.
You are?
So now, if you want to avoid me, you can. There are other people teaching 280, and I could talk about them. But I am teaching 280. I always like to try to teach the calculus, bam, bam, bam. So I might try to teach Calc 3 the next semester after that, like next fall. I love Calc 3. I would. Yes, Bailey.
So which I would like, I think we'll do it over like 5, either A or I saw you go over B.
Yeah, we can look at 5A. 5A gets a little trippy. Has anyone tried 5A yet? That's the other mean value theorem problem. It looks like it should be easier than B, but it has one little interesting twist. So remember, this is the one about calculus and algebra. So if I do the algebra way, what do I have to find first? Well, in order to find slope, what do I have to find first? Points. So I plug in 1, and I get 2 minus 4. I plug in 3, and I get, I don't know, I get, what is
Negative
it?
18.
54 minus, negative 18? Okay, thank you. Oh, by the way, I think on the key I put my thought process down, but oh, that doesn't matter. And then y2 minus y1 over x2 minus x1, and then this becomes,
-8.
yeah, this will be 16 over, yeah, -8.
positive 18.
Is it positive?
Yeah, because it should be 10. The slope is 10.
Should be 10? What should be 10?
The slope.
The slope.
That was very good.
Oh, yeah, you're right. What happened?
She
So,
said negative. It's supposed to be positive. For the 18.
oh, it's supposed to be positive 18.
Yeah.
Okay, okay. So that'll be 18 plus 2, 20 divided by 2 is 10. Yeah, that makes more sense. The derivative, it comes out to be, this one's easy, so I'll just do it, 6x squared minus 8x. And then when you set those two equal to each other, you have to bring the 10 over. You can divide by 2, and then you get something you can't factor, so you just have to use quadratic formula. Yes? When you use quadratic formula, how many answers do you get? Two. Sometimes it might be the same answer, but you'll get 2 answers. Here you'll definitely get just 2 answers. One of them will be in the interval, and the other one won't. So make it a decimal, you can tell which one is which. So I mean, to be honest, that's what makes this problem hard, is that you have to use quadratic formula, but if that's the hardest thing you have to do in a problem, then that's not a hard problem.
Yeah.
Huh? Oh yeah.
Oh, I see.
Yeah. So do you have any questions? Where's the concave? Up to what? How long is it concave? No. Where's the first place you're good. So what is it after this? Beautiful. So where does concavity change? Good. That is the inflection point input. Right? So you can put it into the function to figure out. Yeah. That'll be the inflection. One inflection point. And then of course there's another inflection. Okay, good.
And then they find out their frequency. Oh, so that's all just a question?
And the intervals, but I mean, you can just list them out. Yeah. Cool. Acceleration is exactly under 20.
So that is the second row.
Yes. So basically, if you don't think about it like that, think about it like there must be a point where the slope of the velocity graph is that. So what's funny is, well, let's see, this is just something like frequency.
I just
Oh,
took it as.
per hour.
Oh.
So what should, so if it's miles per hour, 10 minutes is how much of an hour? Yeah, it's 1/6 of an hour. So let me see what I did. 20,
Right
oh,
here, I just
well,
did-
first off,
I
20
did-
divided by 10 is not 2, but that's what it was throwing me. So it's 20 divided by what you just said. 1/6, which is what? Well, I mean, you know, divided by 1/6 is times 6, which is 120. Now, real quick, does that make sense? You're done. If the straight slope is 120, and you agree with me the velocity function is continuous,
Yeah.
right? There's no way you can drive a car and have it suddenly change from 0 to 70. If you do that, you're dead. So you found the straight line is 120, which means somewhere it's got to have the same slope, because it's a continuous differential function. So there's a lot less calculus involved in the problem. In fact, there's zero calculus.
So then I should just set it up as the difference between the miles per hour
You're done.
over the
Yeah, you're done.
difference in time.
That there has to be a place where your f prime is equal to that, correct?
Yeah.
And if your f is velocity, what's f prime? What's the derivative of velocity?
Acceleration.
So you just showed that there's got to be a place where the acceleration is 120. Yeah, let's see. So let me look here. All right, let's see. Yeah. Oh, oh, dude, alright, okay. The function starts with a negative. That should be negative. And that should be even more negative. Isn't the function this?
You don't.
Oh, I see. Oh, but you went back, you did, okay, you did question, okay, I'm with you. So this is probably fine, this is fine. What's it ask? Oh, sketchy graph, okay, so what you've discovered. If this is true, let's see, it might be true. So then it would have no critical numbers. Does that make sense, Sean? It actually does. Let me think. Yeah. Strangely enough, it has no critical numbers. Yeah. That's kind of tricky. So the first derivative has no critical numbers. So it's monotonic. It's a word that means it's always either increase or decrease.
I'd have to put it, but I wonder perhaps the options, none of them are like that. None of them are just only decreasing.
Oh, did you try just graphing that function?
No.
Yeah, if I were you, the minute I hit a problem like that, I'm like, wait a minute, does this even make sense? Right? I don't see a problem with your work. So I'm really hoping I could have missed something, just another given. But if you graph it, see if there's somewhere that, I mean, obviously it's gotta be doing some trippy in the middle, but effectively it's just going up. For really big values of x, isn't the bottom, where'd it go? Isn't that, don't mean shit? And the square root of x squared is the absolute value of x.
Right.
Oh, that's interesting. Oh, that's true. I think that's okay. Show the question. I think that's too much in there. Because I think that just helps for like, so if x is below 0, this is 1, and if x is above 0, this is still 1. So it effectively looks like it's 1. So that's true. Now I'm curious what that thing looks like. Yeah.
It's just for 5. There's a part that I don't understand. So x squared minus 8x. Where do we get 10 from? Yes, I understand the right. We got
Yeah,
the points.
that's where we got the 10 from.
Can you just humor me and walk me?
We got the points, then we did y2 minus y1
Right.
over x2 minus x1.
I understand. I think I need you to just walk me through it one more time.
What does this mean?
Well, that's the derivative.
Which means,
We took power rule.
no, what's derivative mean? It's the what of a function? Slope. What does this calculate?
I don't know.
y2 minus y1 over x2 minus x1. Change in y is divided by change in x's. What does that calculate?
Okay.
Slope.
But again, I'm so sorry.
What's up?
It's probably best if you come here. There's something about it that just isn't checking out in my head.
So what's the endpoints? I know the input at the first endpoint is 1,
Yeah, it's 1.
and the input at the last endpoint is 3. So then we plug them in, we get the points, and then we get the slope. Slope is the change in the y's divided by the change in the x's.
Plugging in 1 there, that's 2. We're not just plugging 1 and 3 in for x.
Yes, we are.
We are?
Of course we are. How do I get the point where the x is 1? I plug it in. That's this guy's purpose, is to give me the output for it.
Because if I go to, okay, I see it now. And we do, and that's the y2, that's 1, okay.
Yep.
So then it's.
This is slope.
Divided by, yeah, it's 10 divided by 8?
No. I crossed this out because somebody gave me the wrong thing here, but it's okay.
I did.
That's
so-
10. That's slope. That's slope. So we set them equal to each other.
No, I understand, that's what I'm saying.
Oh, okay.
So why is it just the 10 on the left side then?
What do you mean?
What's gonna be? So sorry.
What's 18 plus 2?
Yeah, 18 plus 2, 20, 25 by 2, oh, okay.
Is 10. It's just that because it's just that.
Sorry, I was the existence of the fractions still being there. Okay, I understand now, thank you. Yeah.
Sorry, I was just gonna bring
Okay, I'll be right here. Yes? Oh yeah, this was a cool problem. I love it. Of course I do. How's acceleration related to velocity? So in calculus terms, acceleration is the derivative. Good. So, any value terms says calculate the slope of the endpoints. Your function has to have some place where it is. The slope of the function is slope of the function particularly is gonna happen at least in one place. The slope has to be equal to this. What's the slope of the function? What do we call it? The slope of the function. Yes. So the acceleration has to be equal to the straight line. Can you find the straight line slope? Miles per hour. How much? What's the difference in the velocities? Good. And how much time? And we need per hour. 10 minutes is how much? Right, always the day of the next test. So, it's fine. Yeah. So you guys, everything's due the day of the next test except homework corrections. Yep.
Alright.
What's up?
Time I go back, I got something wrong on it, some numbers are fucked up. Or something. No, just not. Put it all together.
So how'd you see that?
It's 81.
When you plug a 0 in, you get 9 times 9. Hold on. Because you didn't put the function in there, you put, so you have to look at the y2. So that's y2. Yeah. Oh, dude, you ready? This is so easy. This is x times -3. Yeah. Now, if you do your table. Because it was doing 3x, and of course 0 makes 3x.
Okay,
That's all it takes.
How
If something
does-
like that happens on a test, just come up and see me. It's more likely some syntax, some weird shit. Which is annoying. Very cool.
How does that S at -1 equal -1?
I don't know. I did it in my head.
So I had
So that'd be
0.
-2. Oh, because what's -1 squared?
It's 1.
Plus 1.
Oh, 2.
Yeah.
Okay.
The point is, the bigger I let the bottom get, what's happening to the answers? 2 divided by 100, 2 divided by 100, so 2 divided by 100 trillion. Yeah, so what's the limit if I just let that happen forever? There you go. That's the idea of a limit. We can't get to infinity, but infinity is a process. What if we just let it keep going forever? Well, eventually it would get to 0. If you were able to let it go forever, it would get to 0. Yeah. You're welcome.
So, 5's answer is just that.
Do it again.
It's just this. I guess that's a function.
That's an equation. You solve it. You can divide everything by 2, and then if you try to factor it, it won't work, so then you have to use quadratic formula.
Well, just hold on a moment, because it's an equation, but like, what is getting solved?
Try to solve for x.
Oh,
Normally, if you have a higher power on your x, you try to factor, and if factoring doesn't work, you do quadratic formula if it's a quadratic.
Why do you want us to scale 81 on
Go 20, 40, 60, 80. I mean, you see what I mean, Jason? You get to pick scale.
Yeah,
You
but
get to
it
pick.
doesn't make sense. Though. You have to big numbers and then a giant number on 5 squared.
Well, you want-
It goes up to 80. When it's down to 0, so.
Yep. So if you do 20, 40, 60, 80, 81 definitely has a place, right? Really close to 0. But, no, so we're.
So I'm not stretch.
You can kind of exaggerate a little bit.
I said
It's
so.
okay, but it's not really worth 3 technically. You see anything?
Man, I'm not gonna be able to finish all the homework. I'm barely done with 4.2.
Plot exactly.
I'm almost,
3
I have like
on a
one
scale.
on each of these,
Going up to
before I
100.
can turn it right.
But it's just kind of not touching 0, but really close to it. That's fine. Yeah, yeah. It's the trade-off we make when we have to make our scale big. There's a bit of a trade-off.
Get in there, get in there.
No. Oh. That's a bit much. I don't know if I can do that. I have to keep the door open, which would probably defeat what you're trying to accomplish. Oh, you can sit over here and stare at the wall. Sit back there and stare at the wall. Stare at the window. And then they're all facing this way. I'd be cool with that. This table, you just put a chair over there. I'm cool with that. Or you could, even if there wasn't one, we could put one back there. Yeah, they're movable. But yeah, I could work for it. Just putting outside is a little much, because then I can't hear what's going on. Right, in the extreme, I could have somebody do that, and then somebody's right over there going, and then you take this out. You know what I mean? You'd be amazed at the things students do, and I'm not saying I think you would do that. I just have to have things applied the same for everybody. But you can sit back there and stare out the window, that's cool with me.
And if you think you have a problem, go to ARC, they'll test you, and then you can get accommodations. Like if you get distracted easily, or they will, it's like a 2-hour test, just to let you know. I didn't know for 40 years that I had a learning disability. So. And it has to do with noise and like being under time constraints.
Also seeing him buzz around.
Huh?
Seeing
Well, you-
Mr. Waller buzz around.
No, I need
No,
noise.
I'm talking about for me.
Oh,
Like,
I need noise. If I don't have
oh, you
noise,
need
then my
like
brain
noise?
doesn't.
Yeah,
work.
that's why I
Like,
have my headphones. So
yeah.
I have to have mine on as well, otherwise I just.
your headphones, yeah. If I don't have my headphones on, I can't even do anything.
Oh yeah.
But like
That's like-
seeing like I just know like he
Okay.
probably can't sit still for long, but seeing him like buzz around like it distracts me so much, and like it makes me anxious when he's next to me, and so like I freeze up and whatever I was thinking goes away. So
I'm not saying that you have a disability.
no, yeah,
but
yeah.
there's nothing wrong with going and being tested for it, because like I said, my whole life,
Yes,
I
again.
passed classes, I got through them, but.
There are benefits and
no,
drawbacks
that's
to
not-
having an official diagnosis. Official diagnosis means you go on the list, which means your
Yeah.
options are limited.
Not necessarily.
You don't need to be officially diagnosed to know.
Yeah. But for like accommodations, like noise.
So not only.
The official diagnosis is just a label. You live with your body longer than anybody will be able to do. You learn what you needed to
It
know.
only works if it's indeterminate.
So just.
I've been diagnosed with high functioning autistic
Every time you.
since I was in first fucking grade, kindergarten actually. I've known what I've needed for a very long time.
Well, then you gotta take advantage of those.
Alright guys, I am going
Gotta post
to,
down.
I'm gonna call it so I can get over to the
I'll go
Sissel.
over to the Sissel on
If you just didn't have enough of me, I'll be over there.
It's so frustrating because it all makes sense.